Hi everyone. Is there any optometristic or eye doctor here? If so, I think you should sit down. Any chance that you're managing to read the slides at the back there? You're managing? Wow. Stand back there. Excellent. So, my name is Alon Kaufman. I lead the data science for RSA. It's a global thing. And I'm also part of the program committee of this first conference. So I was really debating what should I actually share with you. And sorry, I have to walk around. I can't stand there behind. So I was really debating what to share with you today. And there's basically four options. I could boast about my team. We have a lovely global data science team, mainly based in Israel. I could actually start a recruiting process and show you how well the team is, what nice technologies we are, and we're constantly looking for people. I could take a use case, like we just saw from Intel, and walk you through how we do security and data science and security. And the favorite one, I could really scare the hell out of you of what's happening in the security area. So I was really debating, and I thought, like any good show today, let's do a vote. So please, let's just take out your phones and SMS me the number, and we'll just do it more than anything. But seriously, I want to take this audience, take this opportunity to actually call for an action, call for help to this big data and machine learning audience in Israel and worldwide. For the sake of our personal lives, the companies we work in, and really society. We're in dark ages in the world of security. You heard about this, IT security. Any time I say security, it's going to be IT security. And we really are failing to address the challenges we have out there and the goals we have. Kaspersky, I think if anyone was in a cyber meeting about 2 years ago in Israel, said that we on Kaspersky, the guy from the Kaspersky antivirus company, said that we are on our way back to the ages of riding horses and using pencil and paper. And we really are, at the time I thought he was exaggerating. I still think it's not really there, but we're heading there and we are on that journey. And what I wanted to do today is actually show you where we stand in terms of security and how this community, these technologies of big data, of data science, of machine learning, has a critical part in really transforming the way security operations are done today. And we're on an inflection point, and it's a critical stage to jump in this and change the way things are done. So I assume most of the audience is not expert in security. I myself wasn't before I joined RSA. So just a little bit what I'm talking about. The threat landscape. So in terms of the attacks are getting more aggressive, more complex, coming from everywhere on everything. Now when I say aggressive, it's on all levels, nationwide. Power plants, the plans of the F-35 have been gone to China. On personal levels, so nude pictures out of Apple. Yeah, you just saw what happened to Sony. So on every level, we've seen more and more disruption. Business disruptions that cost you more money and getting to the age of being even destructive. So not far out there, we're going to have cyber attacks that are going to be destructive. More complex by nature. They're going to get more complex. We as defenders, every time we raise a bar, they have to become more advanced and more complex. So by nature, we're going to see more and more complex attacks, and obviously from everywhere on everything. So all this nice world of open connectivity, Internet of Things, connecting everything, is a great value for us in terms of technology and quality of life, but for them, it's just another way to attack us from anything and really on any piece of data, from CT machines, power plants. We just saw the other day, or 2 months ago, in Mobile World, a demonstration of in a smart house. If you flicker the lights with an amplitude, with a frequency of beyond 200 hertz, globes explode. So there was a demonstration how a hacker can actually explode globes in your home. So that's where we're standing today. And in terms of where the defender side, in terms of how we actually address this, we operate in this fundamental way as security is done, by the way, in any kind of segment all over. So we collect data, we monitor what's going on. We try to detect the alerts or the attacks. We then go and investigate them, and finally respond or take action based on them. So this is basically the fundamental doctrine that we do security. And in all of these areas, there's huge investment. So we have firewalls, and then we have the next generation firewalls, and next generation firewalls, and same for antiviruses, anti-malware, security information management systems, and so on and so forth. So all these technologies fall into one of these four buckets. But reality shows the following picture. And this is from 2014. We're losing the battle. So just in 2014, for those that can't see in the back, there's an increase of beyond 50% in the number of confirmed breaches. So not only the number is going up, also the level of aggressiveness is going up. Those of you that can see, there's an interesting graph here. The orange are the bad guys, which is the time to compromise. How many of the attacks actually takes them less than 1 day to compromise an enterprise? So you see the majority of the organizations can be breached in less than 1 day. The blue lines are us, the good guys, trying to defend. And in our case, the minority of cases are actually detected per day. And what's even worse is that the orange line is growing faster than the blue line. So whatever we're doing, we're seeing more and more attacks, and they're getting better, and we're not managing to close the gap. And that's really the situation we are in today, with all the money and all the technologies flowing in. So what's really, this is just from the internet, by the way, breaches from April. You can see about 2, 3, 4 reported breaches per day. Unfortunately, I can assure you that probably most of your enterprise are breached or compromised. The sad fact is that most of your companies don't even know you are. And even if you knew, you probably couldn't even find what's going on there. This is the situation today. Less than 5% of the attacks are detected. From the vicious attacks, which are called APTs, Advanced Persistent Threats, less than 1% are actually even detected. And that's our reality. So, how come? What's really going on here? I mean, we have spending on IT security going up. We have all these amazing technologies we heard about today and others. We have good people working on it. I just came back from RSA conference. 33,000 people for 5 days, beyond 500 vendors presenting there, everyone showing the top-end, top-notch solutions to solve the problem, and yet we're losing. So how come? What are we missing? You heard a little bit this morning from Renir as well. There's an endless amount of technology and so on that we're obviously missing and that we should be doing. But there's something much more fundamental. The first thing is that the attackers, operate in a much more known world. Meaning, they decide who they're going to attack. They decide what they want to attack. They can then learn the organization and see what solutions are there to defend. They can learn from conferences, from the internet, from whatever, what these systems do. And hence, for them, when they come to attack, things are much more clear, much more known, much more predictable. At the end of the day, their lives are much, much easier. What's happening to us, the defenders? So the way security is done today, we are very slow. We are reactive. It wouldn't be a huge exaggeration to say that we wait to be attacked, and once we understand how we have been attacked, we try and then find the way, okay, we were attacked from this angle, let's quickly put a rule that stops that attack. And yeah, okay, we may be good for that attack, but we actually totally open from all other attacks. So the way we do security today is reactive, which causes us to be very slow and definitely not addressing the future attacks. The other thing is that we're running into a huge skill gap or human resource shortage. Why? First of all, more and more companies need now security operation teams. But the way these security operation teams work is that they spend most of the time manipulating, tuning, and operating the technologies versus using them. So I'll say this again. Security teams today spend most of their time tuning, working, manipulating, mastering the technology, and not necessarily using them. So it's not typical to find masters for each pinpoint solution, and that you have to have highly skills of people using these tools just to get them even working the right way. And beyond all that, we're simply not making their lives hard enough. So a huge percentage of the breaches I showed you are actually unknown vulnerabilities. So things that are published that they're vulnerabilities and are not patched yet are still the main reason or the main way that the bad guys get into the door. Moreover, if one organization is attacked, it doesn't help any other ones. The ability or our ability today to share information, to transfer knowledge is close to zero. So instead of us, the defenders, actually operating in a united way against them, they can't combine forces. They have different political agendas behind them. We, as the people being attacked, the corporates being attacked, can combine forces and actually attack them. We're not doing this. So these are some fundamental, leave aside technologies, leave aside people solutions, some fundamental things that we have to change when we come to do security and change dramatically the way we're doing it, because the current way, it's not a matter of more money, it's not a matter of more people, it's not a matter of more technology. We have to change something fundamental. So before I carry on, I just want to go a second to a different world. Anyone knows what this is? Someone has to know. So excellent. This is a radar. This is the aviation radar from a fighter plane, actually a Phantom that was introduced in the 60s. And what was the purpose of this radar? It was to allow the pilots to see beyond view range. So up until then, people could see, let's say, 4 or 5 miles if you've got good eyes like the people at the back there. But it's not enough. So we wanted to see more. The world wanted to see more. It went and invented radars that can see, at that time, let's say 20, 25 miles ahead in order to detect the enemy before him. It was not easy to manipulate these things. So you have to actually set the right azimuth, set the right elevation, play with the game, try and lock on these little white dots. Once weather used to be a huge barrier here, ground terrain and so on. So it was really hard to do this, yet it did allow extra visibility. By the way, this technology actually required a doubling of the head count. So fighter planes went from one-seated planes to double-seated planes just to have a radar operator or system operator at the back optimizing these systems. Sounds familiar a little bit? Fast forward 50 years, same company comes up with the F-35, and this is how the world looks today. You have what's called the tactical situation display. This actually automatically scans all the area, locks on all the airplanes in the place, also ground threats, classifies them, counts them, knows exactly how many are there, where they're heading, what ammunition you have, and basically provides the pilot a picture showing him what is in front of him, what is more dangerous, and what he should be addressing. By the way, this, with a reduction of 50% in headcount. So we're back to one-seater planes with much more context, much more visibility, and enabling the pilot to take decisions and not manipulate radars or to create this picture. Let's just look at it. Anyone knows what this is? So that's Google's self-driving car. What we basically see here is basically a little bit more than a century of the automotive industry, where cars, again, from requiring people to drive them, manipulate them, operate them, we got to the stage that cars drive automatically. Cars can finally take us from place A to B without us doing anything. And of course, same analogy goes here with the fighter planes I spoke about. So what we've done in these two areas, and obviously many more, we reduced or removed the need for the human to operate the systems, to tune them, to optimize them, and we actually put him in the place that he uses them and makes decisions on top of what they're providing. This is where we should be heading in terms of security as well. So we have this terrible graph, which describes where we are. I showed you or conceptually where we should be going. How do we really get there? So we have to dramatically change the way security is done. These are all kinds of technologies that people spend tons of money on and been developed for decades and decades. And each of them is actually, by the way, essential, but none of them are sufficient. We have to take all these technologies we have, which in the world of security is the data we're talking about, or the pre-processing of this data, combine them into big data platforms, in our world it's called security analytics platforms, that provides us what I spoke about before in the fighter planes. A comprehensive view of the world, identifying the attacks, prioritizing them, allowing us to do it much faster, much more accurate, and use human intelligence in order to operate or react to them and not build these pictures. This is where we're heading, and that is, of course, where my team is heading as well. So how would this look in a security world? So obviously, most of you are not security guys. As I said, what happens in a security operation system today is that the people come into work in the morning and start sifting through thousands of alerts. And basically spending more time on tuning the system that tomorrow they'll have 5% less alerts and deciding on what to work versus analyzing them. And of course, if you work in this way, you have many false positives, and the whole process of this reactive slow world starts. We would like to move to this kind of world where you wake up in the morning and you see who's attacking you. What attack vectors are there? Not single alerts here and there, but combining these alerts into a map like this, that you understand the situation of the attacks in your organization. It guides you to what's more important to deal with. And obviously provides you a much more comprehensive view, learns. So if I'm analyzing something day after day, the system should learn. If I'm not using something, the system should learn. If I'm classifying bad activity, the system should learn, and so on. So we want to get to this world, in fact, that it operates on all our data, not in a priori reactive mode, but in a proactive mode, provides all the data you want, and allows learning and human ability to react. We don't have to check, there's nothing here changing conceptually from the collect, detect, investigate, and respond model, but we're talking about detecting, not alerts. You want to detect attacks and campaigns and adversaries attacking you, not if a user failed 5 times to log in. That's not interesting. You want to see who's trying to attack you and what it is. When you come to look at a case, you don't want analysts to be experts in writing SQL queries and so on. You want them to get all the data at once and really understand what's going on there and learn from their activities. So anything time they do something, you add it to your system. And obviously, what you can do automatically and respond automatically, do. What you can't, and you can't in all cases, let the humans do it and learn from them. The key here is, in medicine, in security, in some other verticals, is not to replace the humans, but is to combine forces with them, to provide our systems that leverage them to produce much more better quality and faster results. So how do we get there? Why am I talking to you about this in this big data track? So data is not our problem. We have huge amounts of data. I've tried to quickly describe to you the problem. And for me, data science is simply solving the problem using and manipulating the data. Now, we have to transform the way security is done, yes. It's not only a matter of data science, but data science and big data analytics is a key component in it. And if there's one message I can get out to you today is think about the technologies you use. Think about all the tools you've been developing and see how they can be applied to this need. Because we're not managing to do it today, and it's critical. It's not just failing to do a recommendation engine losing money. We actually are going and are heading to the world of horses and pen and pens and paper. So how does this look? It's not very different than any other big data system that you would see. We have to take all data from all different systems, log data, network data, email data, social data, anything you can have on any of your employees, any of your systems, any of your partners, put it into one central place and operate on that. And operate what? Exactly in the lines of what I've been talking about, which is really doing much more advanced stuff in a different way. So where does data science come in here? So obviously we want to be more comprehensive, more predictive, more utilize human intelligence much more, and yet we're not going to change the fundamental way security is done by detection, investigation, and response. So what I'm actually talking about? The use of data science built into these systems is a critical path we have to take. And I'm not talking about endless startups popping up, doing detection in some different way, or new algorithm for anomaly detection, and so on. So yes, we need them as well, but we have to start detecting attacks, meaning combining all these small alerts into attack patterns, attack vectors. We're talking about aggregating all these things and prioritizing them, telling the analysts what to do first. What is the impact? What is the risk around this? Why do you have to deal with it? When do you have to deal with it? Go into a more predictive and forecasting kind of attitude of knowing what's going to be attacked and how it's going to be attacked. And obviously, a key component of it, which we invest in a lot in, is really using crowdsourcing in security. So not having these siloed teams all over the world, but combining their forces, learning from one to each other. Within security teams, learning from good analysts to teach the junior ones. Having the bigger companies and with a better kind of security operation teams, influencing and learning the younger teams what to do. That is where we're heading, and that is where basically my call for action comes from. And to not leave you just with this statement, I want to show you an example. It is a more simple example where we didn't lose the battle, where we're actually winning the battle. And some of these concepts have to be moved to the general use case. So already Matan spoke about the fraud area. And this is an example where in financial fraud and e-commerce fraud, we have solutions deployed which follow this logic I've been talking to you about. And the goal is really to transform this into the general cyber space. So in the world of financial fraud, the world is quite simple. You want to do two things. You want to stop fraud, and you don't want to impact your users. So they still want to buy with one click. They still want to move money from their mobile, but they don't want to be questioned too many times, you know, your name of your grandmother, your dog, send an SMS, and whatever. So you have two conflicting things here. You want to stop fraud, but allow more freedom to users. The way the system works is basically the user logs in, can be from your desktop, your mobile, whatever, and behind the scenes in real time, the risk is calculated. The risk is calculated obviously based on a machine learning algorithm that takes into account crowdsourcing and all different kinds of technologies I won't go into, and in real time calculates how risky this transaction is in an invisible way. So the user doesn't know anything about this. Now if the transaction is not risky, it goes by, and basically the user doesn't even know that something happened behind the scenes, and the usability or the one-click shop actually worked. This actually happens for beyond 99% of the cases that they're not risky, they're not fraudulent, and they go through the engine. However, if it is risky, only then do what we call step-up authentication. Only then send them an SMS, only then ask them the name of the dog or whatever you want it to be, or voice recognition or face or whatever. The user passes this challenge, great, the transaction went through as well. If it fails, only then it really goes to a human analyst. But the nice thing here is that we feed back to the engine what's happening. We feed back if the user passed authentication or not. We feed back if the analyst defined it as fraud or not. And this is how the engine learns. So I said the world is going to constantly get more complex because whatever solution you put there, the adversaries, the attackers, the fraudsters will come and overcome. So you have to have built-in online learning services like this kind of logic. And by the way, in this world, we really, in terms of performance, less than 0.5% of the transaction actually take this path, and we still stop beyond 90% of the fraud. Beyond $5 billion a year, stopped by such systems. Now, the key of the system, leaving aside a second the algorithms here, is that the whole system is built conceptually different. It's built around the fact that you don't know what attack patterns you're going to face. It's built around the fact that you're going to have to learn as you go the new attacks because the fraudster will constantly find them. And it's built for the deployment. Ease of usability in terms of the users and so on. And in this case, this product is being already deployed in many thousands of customers. We go more than 30 million transactions per day, and this is already very successfully deployed. This is where we should be heading in the general cyber world. We're not there yet. My team and me and myself are working very hard to get there, but these are the challenges we have to look at. not pinpoint small solutions, but conceptually how we design the new security tools around data science, machine learning, and obviously dealing with big data analytics. So to summarize, the current situation is that we're not managing to deal with the threats against us, and the world of cyber is actually failing, or the cyber defense is failing versus the cyber attacks. One of the key things there is that we work in a reactive mode, and we use our excellent people there to tune and build the system. It's like, just imagine, instead of using a search engine, that you get that you're tuning parameters of the search engine just to find your results. So instead of us using the search engine and getting results, you're actually constantly trying to tune it to your goodness. So that's what's happening in security today. And the way this, one of the solutions, of course, data science is not the only one, but one of the ways to go there is really building big data science systems that really take us to the next level of getting these tools to work for us and getting the humans in the loop to actually operate on them and define intentions and strategy how to use them and not waste their time by tuning them. So I stood by time. We're constantly hiring, so yes, after all, I still want to get CVs if relevant, but I want to open up for any questions if you want, be it on conceptual or what kind of technologies and algorithms we use. Okay, thank you very much.